to the InMage webinar today. We're going to talk about just really if you're prepared for a disaster, whether it be natural or whether it be man-made, and how InMage can help simplify that total and overall process for you there. So as we go through the presentation today, we'll just simply talk about kind of what is a disaster and then how InMage can help prepare you for protecting against that disaster and how to get your systems back running again. We'd like to remind everybody that disasters aren't necessarily that huge catastrophic event. It's not necessarily that big storm or, earthquake or tornado, whatever it might be. More often than not, it's something that happens in the data center itself. And when something happens in the specific data center, the expectation from the business is that you should be able to recover very quickly. So whether it be a power failure, hardware failure, or frankly even human error, the expectation is that situation should be able to be remedied very quickly and be able to be brought up. And that's what InMage does. Whether we're protecting an entire environment and you need to fail over from a full site outage, perhaps the entire data center has gone away or lost power for some reason, or if it's just one or two critical machines that need to be brought up and protected and brought back online, InMage can help you with all of that. So what is InMage? InMage really, in a sentence, is a network-based, block-level, asynchronous, continuous data protection solution. And I know that's a mouthful, but really what we're trying to say there is network-based, meaning we're going to follow any of the TCP/IP standards or any TCP/IP environment that you've set up in your environment. So whether there's NATs or PATs or whether there's VLAN segments, it doesn't matter to us. We'll go ahead and sit on top of what you've designed, and we're going to go ahead and replicate that data using the existing network that you have. We also have the capability to modify IP information between two data centers. So when we're failing over to a second data center, if it has a completely different IP scheme, then rest assured that we'll be able to pre-apply that information and that IP scheme over there. Block level is just that. We're agnostic to disk. We're going to go ahead and protect the storage at the block level by monitoring the changes as they occur at that block level. And we're doing this in very small change increments. We're doing it in 4K increments. So it's very optimized as far as monitoring the changes on your production server, as well as replicating that information to the remote location. Asynchronous basically means there's no distance limitation. We can replicate to the cabinet next door in the same rack. We can replicate it around the world. We can do one-to-many and many-to replication. It makes no difference to us how you establish that replication or where the source and target locations are. And then again, that continuous data protection. We're monitoring every single millisecond of that data change as it occurs on your server. So with us being able to do that, we're actually giving you the ability to roll back to any millisecond in time and present your data. So you literally could say, show me what my data looks like 10 seconds ago, 10 minutes ago, 10 hours ago, 10 months ago, and we would be able to present that data to you exactly as it looked at that moment in time. You could think of this as kind of like a DVR or a TiVo for your data, where you can simply rewind your data set and present that data at that moment in time. We also offer application consistency and application availability. We are monitoring every single millisecond of data as it replicates through. But in addition to that, we have intelligent monitoring at the block level, meaning we're understanding and we're recognizing what applications are running. And we're able to work with that application to provide a consistency point and to allow you to have a guaranteed or a known point in time. If you were to choose that point in time and recover to that point in time, the application would come up in a happy and friendly mode, and it would be able to start operating against transactional I/O. And so you would be able to go ahead and say, show me what my Oracle data looked like at a consistency point 10 months ago. When you recover that data, Oracle will simply come up, and it'll be ready to handle those transactions. You don't need to quiesce the data set. Similarly, it might be Exchange. There's no need to flip the dirty bet if you fell over Exchange. Or really any application in the environment, we have the ability to protect it. Regardless of the environment that it's running on, regardless of the operating system, whether it's Unix-based, whether it's Windows or Linux, We have a wide range of support for all of those operating systems. Linux includes all the majors, whether it be Red Hat or any Red Hat derivative, whether it's SUSE, Ubuntu long-term, we have Debian, and we even have Oracle Iron Linux capabilities built right into the product there. Of course, because you're replicating and you're keeping track of every millisecond, we give you the ability to fail over and fail back. So there's really no distinction as far as InMage is concerned. If we're protecting your data, you have that ability to fail it over to a DR center. You can operate against that data, recover and repair whatever the issue was that caused you to fail over, and then simply replicate in reverse and fail back to that point in time. We also don't distinguish between the type of environment, whether it's a virtual environment or physical environment. We protect all the servers. It doesn't matter if you're running VMware or Citrix Zen or Microsoft Hyper-V or even an unsupported virtualization platform. We protect that, and you can group those servers, both virtual and physical, together to create protection plans if you need to create protection across those environments. So we do have WAN optimization built into the product itself. It'll simply monitor and optimize that replication for the wire. It adds compression, it adds encryption, and basically gives you full control over what that WAN replication is going to look like to ensure that you're managing your bandwidth appropriately. Also, we have full SLA monitoring. So if you have service level agreements that you're trying to meet and you need to do reporting off of those service level agreements, you can go ahead and do that. And you can track that not only graphically, but also there's numeric content as well. So we have a quick question here about the difference between different solutions such as SRDF, SRDF-A, Oracle Data Guard, and different things like that. It's a great question to address right now. The biggest difference between those is the method in which we're monitoring that data. We are agnostic to the storage vendor, so we're not going to lock you into any type of storage. You can run Tier 1 storage at the primary site. You can run Tier 2, 3, or even Tier 4 storage at the secondary site if you would like to. We are doing asynchronous replication, and we are doing it at the block level monitoring. We are doing it at the logical volume level of those servers. So we're not going to lock you into replicating a full LUN, so there's no LUN-to-LUN pairing, there's no LUN-to-LUN matching, or anything like that. And in addition to that, we're not working only with the application relying upon archive logs that are being written. So in Oracle, you have the archive log recovery process that DataGuard leverages. And Windows, there's archive logs as well that can be replayed, such as transaction logs. We don't necessarily worry about that information because what we have the ability to do is when we quiesce that application, what's happening is we recognize which blocks of change have occurred at the storage level, and we simply insert a flag or a marker immediately after that last block of change for that point-in-time consistency, and we replicate all that information over. So we're not taking snapshots, we're not doing copy on write or copy on read logic. It's actually extremely lightweight. We're just simply flagging that very moment in time of when the application is consistent. And with working with applications in a Microsoft world, we actually leverage VSS, or the Volume Shadow Copy Service. We don't care about the shadow copy portion, but the very first step of VSS is to create that consistency state, which essentially flushes any pending write out of memory down to disk. In the Oracle world, we work with the RMAN and any other applications out there, whether they be Postgres or MySQL or anything like that. We work with the tool that's been provided by the application vendor in order to present that consistency point of the application. We do have some new information as far as new capabilities that have just been released with the product. And so this is the latest of the support matrix that we have. Certainly we support all the older operating systems that we've already supported, Windows 2000 and newer, so on and so forth. With the Red Hat, we go back to 4, update 6. But the latest and greatest is Server 2012 in the Windows environment. MSCS clusters are now supported, as well as the Hyper-V 2012 environment is fully supported. We do have the latest versions of Red Hat that are supported. 6 update 4 has been released, and that we're typically a few weeks behind on those Linux releases simply because we get the information released at the same time the public does, and so it has to go through some testing there. And then you'll also notice on the AIX side, we've now added 7.1 and 6.1 clusters to our AIX environment support there. The other thing that we're doing is we're actually really working well with large workloads. We're including whether it's P2V migrations or whether it's V to V, we're actually pushing the limits of that virtualization platform. We're running protection on systems with multiple terabytes of RAM, even greater than 2 terabyte LUNs. We actually have a customer that's running a terabyte LUN into a single VM, and we're handling that protection just fine, and we're optimizing that replication without any issues there. We've expanded our protection coverage, whether it's virtual to virtual, V to V, whether it's P to V, physical to virtual, migrations real time, whether it's virtual back to physical. Just because you want to do a physical machine into a virtual machine for DR to simplify that DR environment and to lower your costs in that DR environment does not mean that InMage is going to lock you into that virtual environment forever going forward. We give you that capability to replicate back out of that virtual environment back into the physical machine if you so desire. So really, we like to call it anything to V, whether it's a physical machine, whether it's a disparate hypervisor that's maybe less known, we can actually virtualize that and give you full protection capability and simplify that failover. In that same line, we've increased our protection on the Linux environments for P2V and V to V, as well as the Microsoft Cluster Services. We can now do P to V on Microsoft Cluster Services, as well as V to V if you would like that as well. And then we've added UEFI support. That's the later release of traditional BIOS. And so on any physical servers that you might have today or will be getting in the future, that support is already embedded into InMage, and we're able to protect those servers just fine. In addition, we have full VDI support, or virtual desktop environment support, and we, again, protect it across multiple hypervisors. We're not going to lock you into any specific solution. Whether you're going to go with VMware, Xen, Hyper-V, it doesn't matter, nor does it matter what the guest operating system is, whether it's XP through Windows 2008. We can provide that support on those master VDI servers so that you have the information you need to when you spin those machines up. We also introduced a new interface, a very clean interface. It's very easy to navigate. We'll be able to see that as we go through the demo environment today. Some of the other technology that InMage has that sets us apart is we have sparse retention, and that's the ability to customize how you retain those application consistency points as the data gets older. So with traditional CDP or continuous data protection where you're monitoring every single millisecond, if you wanted to keep, say, a year's worth of data, that actually uses a fair amount of disk space because we're keeping track of every single millisecond of change for an entire year. Worse than that, if you were to recover something that's 10 months or 12 months old, it's going to take a fair amount of time to undo every millisecond to get you to that point in time to bring it online. So what InMage has done is introduce sparse retention. What that means is you have the control of how your data is going to look and be recoverable on a long-term basis. So an example might be for the first week, you want to maintain true CDP. You want every millisecond of change available to recover to for that first week. Then maybe after that first week, you want to only have an hourly recover point. Maybe the week after that, you want to have a daily recover point. And then maybe it's a monthly recover point for the rest of the year. Those are just examples of the granularity that you can do as far as understanding and controlling how you retain that information. And doing that, it drastically reduces your recovery time and the amount of storage that you need to recover long or archive amounts of data. The other thing that we're doing is we're only replicating blocks, the change blocks of that information. So we're not replicating the entire block. We're just looking at the deltas of each block, and we're replicating just the changes that are recognized there. We do that to keep that recovery point objective as low as possible, as well as optimize your bandwidth by only sending those delta changes. Additionally, to focus on that recovery time objective, we want to keep that as close to 0 as possible. We do not do any deduplication of your data, so there's no need to rehydrate that data either. So that allows you to keep that recovery point objective in the minutes. it's not uncommon for InMage to fail over a system in a virtual environment in just a couple of minutes, or even a physical environment in under 10 minutes, and bring that up. And that's because of those two capabilities, the block level deltas that we're sending, as well as the ability to bring that data online immediately once you decide you need to. Application-specific support and recovery are across all supported platforms, so it doesn't really matter what's running there if we recognize that application, whether it's on a Unix environment or a Windows environment or anything in between. We'll be able to provide you application consistencies across those environments. Everything here is really to minimize that downtime and data loss, or keep that recovery point, recovery time objective as close to zero as possible. We also have some added features for Exchange. We have the ability to do message level recovery. So within a minute, you can actually select the Exchange mail store. You can select the date and time you want to present it as, and then you can actually navigate the users in that mail store, and you can navigate the items, whether it's a mail or a calendar item or a contact, whatever it might be, and you have the ability to extract or export that information, or more importantly, you can push it back into the production mail store and provide access to your users that way. There is no PowerShell scripting that needs to be done. There's no Exchange environment that needs to be running in order to do this. It's done completely offline, and it is done without interfering with replication in any way. Similarly, we have the ability to present virtual snapshots. That's the ability to present any volume at any point in time using zero additional disk space, and it does not interfere with replication or protection in any way. And you can present, say, a SQL database in read-write mode, and you can run transactions and you can run test queries against it. And when you're done with it, you simply release that instance. Whether it's SQL, Oracle, or just a simple volume, it makes no difference to us. So general architecture, InMage is a host offload solution. There is a data tap that monitors the write I/O and passively duplicates that write I/O and sends it down to a process server. The process server does all the heavy lifting. The process server does not have to be an appliance like is represented here. It could be a guest within your virtual environment. It doesn't matter to us. But it'll do all the heavy lifting, caching, queuing, compression, bandwidth management, acceleration, all the reporting that is needed. On the secondary side, if you're dealing with physical machines, say physical-to-physical replication or an unsupported virtual machine environment, we simply deploy the data taps on that side, and we're replicating at a block level those logical volumes. We also, on the secondary side, have a control server. Again, it doesn't have to be a physical box. It can be a virtual environment if you would like. But it manages all the process servers. So as you scale out or scale up, the control server will give you a single UI and manage your entire environment, creating a parent-child relationship between that process server and the control server. Also, by separating those functions, if you were to have a full site outage, you have the user interface, you have the data replicated, and you have the retention file all located on the secondary site so that you can bring that information online very, very quickly. We also offer many-to-one, one-to-many replication. You can consolidate down to archive to tape if needs be. If you want to keep, say, 17 or 21 years worth of retention, then there's probably a need to archive that off the tape. We can simplify that function while giving you CDP capabilities for your day-to-day recoveries, but archiving, say, weekly or monthly off the tape for that long-term retention requirement. As we support all kinds of virtual environments, we're going to simply highlight VMware today. VMware, an example of how we protect VMware would be whether we're doing a P2V or virtual to virtual. On the target side, you would have your vCenter environment built. You would have a master target server sitting there called the vContinuum target. You would simply select the machines that you want to protect. We would grab a copy of the metadata of those machines, and we would modify the metadata if you would like, IP, CPU, memory, such things like that. And we would build a ghost copy of that data, of that server on your secondary site. Whether we're doing a real-time P2V convert or whether we're grabbing the metadata right from VMware, it's the same process. We will then automatically provision the storage to the vContinuum target as needed so that we can establish many-to-one replication and protect the system and data volumes across the board of your primary site, replicating down to that vContinuum target. When it comes time to recover, you simply select the recovery option or server that you want to recover. You select the point in time that you're going to recover to. At that point in time, the vContinuum server will roll back the storage. It'll detach it from itself and attach it to the appropriate guest that you're bringing online. It'll apply any metadata settings or allow you to modify them again, and it'll power that machine online and bring everything up and running for you. So we can simplify that process of failover. There's also options for doing non-destructive DR testing, and we have similar scenarios whether you're dealing with AIX, dealing with LUNs, Solaris Zones, Hyper-V, Zen Server, it doesn't matter. It follows a similar function and similar capabilities there. Now I'd like to hop into the lab here, and let's just do a quick representation of failing over a SQL server. And once we're in the lab, what you can see is the very first thing is we have a high-level dashboard. In this high-level dashboard, it basically shows us a couple of pie charts. These green circles are pie charts. Everything's happy. And it tells us servers are protected and protection plans. Remember, we can group multiple servers into a protection plan. Down below, it tells us exactly what's going on in our environment. We have a control server as well as 2 process servers. All the colors that you see here are color dynamic, so you'll be able to quickly recognize that there's an issue that needs to be resolved. We keep our alerts very easy to read over here on the right. You can filter them down by errors, warnings, or notices. And you can also filter into the specific servers. If I select the Servers tab, you'll notice I have a list of servers here, and I can actually choose any one of these servers, and it'll give me the detailed information on the right-hand pane of what that server is. It tells me the source machine, which process server it's going through, the target machine, gives me my current RPO, my recovery point objective of that server, gives me my recovery window, my available consistency points, and if I scroll down, it tells me exactly what's going on a specific logical volume basis. It gives me that real-time RPO as well as which volumes are under protection there. Similarly, if I choose the Plans tab, I can select a server or a plan, and it'll tell me which servers are involved in that plan for that failover. And I can go into detailed plans, and I can also get detailed reporting and SLA reports out of this screen here. Right now, what I want to do is actually bring up a SQL server. We're going to do a VMware failover. I'll just connect into the console here. And then what we'll do is make sure that SQL is running and has data, and then we will go ahead and fail the SQL server and fail it over. And you can see that SQL Server is opening up. And we'll just validate that we should have a table with a database with a couple of tables in here. There's our InMage database, and we do have a couple of tables. So we'll run a quick query there. Got a cheap file that I can use, so I don't have to type everything out with you on the line. And then we'll just run this query to make sure we have data and show that we have data there. So you can see that we have data in this table. Now what I want to do is I'm actually going to fail this server. I'm going to go back to my vCenter environment. I'm just going to power it off. I'm not going to shut it down or do anything nice. I'm just going to essentially yank the power plug on that machine. It gives me a warning that I probably don't want to do that. I'm going to confirm it anyway. And we've now entered into a disaster where that machine is not available to us, and we can't do anything with that machine. So the next thing we need to do is actually go through recovery. When working with VMware, we actually have a wizard interface that will filter out all your protection plans, just the ones in VMware. We'll select the plan that we want to manage, and we'll tell it that we're going to do a recovery of this. The next thing that it does is it'll actually query the machines that are available for recovery, and I can select one or multiple machines that I want to recover. Today we're just messing with the SQL server, so I'll select that one. The next screen, as it refreshes for you, gives us the understanding of what's going on. It actually is communicating with that master target server, and it's saying, hey, I want to recover this SQL 2008 machine. What are my recovery capabilities? When are my consistency points? What volumes are under protection? How far back in time can I go? It collects some general information, and it'll automatically return it to the system. Once it returns to the system, I can select a recovery action. Whether it's the latest tag, which is the last known good consistency point, the latest time is the last millisecond, or a specified tag or a specified time. I can then just simply run a readiness check. The readiness check will actually validate the point in time that you've selected, that it is an accurate point in time and we can recover to it. If there were any issues, you'd get corrective actions available. Here's where we could modify the metadata if we would like to. If you pre-configured your metadata, you simply don't have to do anything and choose Next here. At this point in time, you can select the order of operations in which you recover. If there were multiple servers, they'd be listed here, and you could do that order as needed. You can select recovery now, or you can queue it up for a later recovery. And based on the operating system, you can use WMI if it's a Windows-only recovery, and it'll bring everything online. I now will select the recover option. You simply have to authenticate into that master target server. And assuming that I didn't fat finger anything, the process will start. Now, what we want to look for as we're doing this is what we're going to see is we're going to see feedback in this section right here within the VMware or within the vContinuum InMage tool. The other thing that we're going to see is we're going to see some tasks occurring down here below. What's happening right now is we are communicating with this master target server, and we're telling it that we want to bring this SQL server online at the last known good consistency point that's available. So what it's doing now is it's discovering which volumes are associated to that SQL server. It's discovering when that last known good consistency point is available. And it's going to go ahead and start rolling back each of those volumes to that point in time. And so when it does that action, it'll identify each of those VMDKs, and it'll actually roll it back, and then detach from master target, attach it to the SQL server, and then power it online. This process takes a little bit of time depending upon basically three things. The first thing that it is how far back in time are you going? The further back in time, the longer it would take. For instance, 10 months will take longer than 10 days, will take longer than 10 minutes to recover that data, simply because there's more transactions that need to be undone to get to that point in time. Similarly, if it's a very busy server, a server that's actually running a lot of transactions versus a dormant server or a file server, again, there's more transactions per second that need to be undone in order to get to that point in time that you've recovered. And the third thing, which is probably the least of all, which is just the raw horsepower and capability of that target environment to process that information and to bring it online. You can see here now that we've got feedback in the InMage system that it's successful and that it's powering online. So let me go ahead and just open up the console, and we're going to see the operating system powering up. And then what we'll do is we'll actually hop right into SQL, and you'll notice that SQL Server will just simply come online, and we won't have to quiesce the data, and we'll be able to extract that information out of a query very easily. Center this screen for us. And we'll give Windows just a moment to power on here. While we're waiting here, we do have another question. Actually, it talks about if there's any interference with the data tabs from an I/O perspective. Actually, there's really not. The data tab, we call it a data tab instead of an agent because it passively monitors the write I/O. It's not actively doing anything. The best way to think of it is a SCSI filter driver in a Windows environment or a key function in a Unix environment, where it just passively monitors that write I/O. Once it sees it, it hands it off to the InMage product to go ahead and be replicated there. In VMware environments, we actually have case studies where you can see that there is no overhead being recognized once that data tab has been applied. I'll simply authenticate into this machine here. And we'll go ahead and launch our SQL Server. You'll also notice that we're going to trigger the event tracker so that that can be handled wherever is appropriate for your environment. So you can log that appropriately, and we'll go ahead and just connect into SQL Server here. And you'll notice that SQL has just started. There's no issues. At this point in time, we would have received an error if there was a database inconsistency. You'll notice we have our databases there as well as the files that we're looking for. And because we failed over the entire server, I actually have my same cheat file. It wasn't that I needed the cheat file to necessarily run a select statement, but I wanted to highlight that we're grabbing all the information on the server, not just the SQL information, and everything's here for us to run and execute our process against. So you can see there that we do have all of our data there. SQL is up and running in just a matter of a couple of minutes. And at this point in time, you could direct traffic here, and you could go ahead and just operate in a normal capacity until the issue was resolved, which caused you to fail over. That's what we have today. We appreciate your attendance. If there's any questions, certainly we'll get to those. If you have any follow-ups, you can reach us at sales@inmage.com. You can also reach us at 1-800-646-3617. Thank you for your time. Bye-bye.